So this is a pacemaker. A pacemaker is an implanted medical device that regulates the heartbeat, regulates the heart to make sure that it remains happy and healthy. Pacemakers contain 80 to 100,000 lines of code, so we have to test all this code. So how do we test it?
That's where our device comes into play. This is the pacemaker verification system. It consists of a couple of components. One is the virtual heart on a chip, which is an FPGA. This heart models the electrophysiology of the nodes and paths that are present in the heart. We can use this to simulate different arrhythmias that a heart like yours or mine could have. We can then interface that heart with an actual pacemaker, and we can see the interactions. We can see how the heart affects the pacemaker, and we can also see how the pacemaker affects the heart in turn. This is a closed-loop system that is unlike simpler testing solutions, where we just give inputs into the pacemaker to see what happens. And this what differentiates our testing system from older and simpler ones.
Our user interface here allows us to program the heart into various conditions from the simple drop-down menu here. Right now, the heart is programmed to beat normal and healthy. However, when we connect the pacemaker to it right now, we can see that the pacemaker actually causes a problem in this healthy heart. And it is this kind of problem that we want to catch before pacemakers are implanted into real patients. If this were a real patient, this problem could be potentially fatal. So our user interface allows us to program the heart into various conditions. Right now, the heart is programmed into a normal, healthy rhythm right now. When the pacemaker is hooked up, we can actually see that the pacemaker induces a problem in the heart. Right now, we see that the pacemaker is causing the heart to beat too fast, and this is called a tachycardia. If this pacemaker were in a patient right now, the patient could be in a potentially serious and fatal state right now. So we want to catch these errors before the pacemaker is implanted in a patient.
So what we have here is an actual Boston Scientific pacemaker that would be implanted in a patient. We can see it interacting with our virtual heart by putting this wand over here and checking out on our pacemaker programmer device. You can see that the pacemaker is actually receiving both atrial and ventricular senses, indicating that the heart is beating normally. What happens if it's not receiving those senses correctly? We can actually see the pacemaker starting to pace when it's going into a feedback loop, showing atrial senses and ventricular paces.